fine. So I think many people will join. I will let them enter the class later. So let's start with our discussion. Let me share the screen. Someone please confirm that whether the slide is visible or not. Are the slides visible? Yes, okay. Then let us start. So in the last class or last session, we did not have enough time to complete all the questions from week 2 lecture materials. So first we will start with those questions, and once we finish those questions, we will move on to the week 3 lecture materials. Okay. And all of you already know that you will have 1 or 2 minutes to solve this problem, and then I will check the chat box for answers, and then we'll come back for the solution of those questions. Okay, so let us start with the first question. So this is our first question. From lecture 2, week 2 lecture material. That is, they asked us to consider a mixture of these following monomers, that is glycerol and succinic acid, and their amount is also given here. They have asked us to calculate the average functionality. Okay, try to calculate the average functionality. The moles are given, and you obviously do know the individual functionalities. So try to calculate the average functionality, and then I will show the solution. You can write the solution in the chat box. I will read them. Okay. I already have one answer here, 2.5. Let's wait for others as well to calculate it and tell me. 2.4, okay. 2.5, okay. 2.5. Okay, 2.5. Okay, so let us quickly see the answer because it was a very easy one. So let me show you the solution. Yes, so the correct answer was 2.5. So we know that the functionality for glycerol is 3 because there are 3 OH groups, and in case of succinic acid there are 2 COOH groups, so the functionality for succinic acid will be 2. Now they have asked us to calculate the average F value, and for average F value we know that this is the formula, that is summation of NiFi divided by summation of Ni, where N is the number of moles. So we have our glycerol, that is 2 moles, and its functionality is 3. Next we have our succinic acid, 2 moles, and its functionality is 2. And the overall mole, summation of Ni is 2 plus 2, that is 4. So that will give us the average functionality value of 2.5. Okay, so this was the easy one. Based on this similar question, I have another problem just with an additional question. Okay, so now here we have glycerol and phthalic anhydride. The moles are given, that 2 moles of glycerol are there and 3 moles of phthalic anhydride is there. So first we have to calculate the average functionality, and next they have asked the extent of reaction at which gelation will occur for this above mixture. Okay, I think everyone will be able to calculate the average functionality. And also please try to calculate the extent of reaction. Just try to remember the condition for gelation, then that will be an easy one to calculate as well. Okay, so take some time and try to solve it, and obviously we'll come back to the solution in a minute or two. Okay, I have average functionality. Okay, just write it down that what answer you are giving. Are you giving the answer for question 1, the average functionality? Okay. Try to solve the second one because I think everyone will be able to do the first one. 0.83, the extent of reaction. Okay, we'll see that. Okay. Those who are writing, try to solve the second question as well. So we have different answer for extent of reaction. Someone has said 0.83. Someone has said 1.25. Okay. Others also please try to get the second answer. Zero point 0.8. Okay, so we have a variety of answers coming. Okay, first one is 2.4, next one is 0.83. Okay. Okay, so fine. Let us see the solution for this. This one also initially was a easy one. So the for the calculation of the average functionality, it is same. You already know that the formula is summation of NiFi divided by summation of Ni. So we just have to put 2 moles of glycerol and its functionality is 3. Now for the next case, that is for phthalic anhydride, it is 3 moles. And now think about it, the functionality of phthalic anhydride in this particular case is 2. Why? Because it has to react with glycerol. So there are these hydroxyl groups. They will react with any COOH groups. Now there are no free COOH groups available, but this OH group can either attack here or attack this carbonyl center to open this ring. So with respect to glycerol, the phthalic anhydride's functionality is only 2. Okay. So if anybody get this part wrong, they should correct it. So for phthalic anhydride, that will be 3 into 2. And the total number of moles is 2 plus 3. And we will get our answer 2.4. So the next part, that is the extent of reaction at which gelation will occur. The answer is correct. Those who wrote 0.8 or 0.83, those are correct. So for those who did not understand, let me explain. Now in case of what formula you have to use in this case. Now if you remember that initially, suppose there are n0 number of molecules. Okay. And after some time, there are n number of molecules left. So how many molecules have reacted? N0 divided by n. Now, every time these two molecules react, the number of functional groups that will react per time, that will be into 2. One hydroxyl group will react with one carbonyl center. So every time it reacts, that will be 2 N0 minus n divided by the total number of functionality that was available. What will be the total number of functionality? Initial number of moles was N0 and we know what is the average functionality of the mixture. So that will be N0 into F average. So that is our formula for calculating conversion of this reaction mixture. That is N0 minus n number of N0 minus n moles are reacting, and in per case 2 functional groups are reacting. That's why we have said it's multiplied it by 2. And initially the average functionality was F average and there was N0 number of molecules. So overall it will be N0 into F average that was available for reaction. So this was our conversion. So when you write it down, it will look something like this. Okay. So it will come as 2 divided by F average minus 2n by 2n by n0 into F average. I have just simplified it, nothing else. Okay. So now n by n0, you know that this n, or you already know that xn or degree of polymerization is n0 by n. Now in this case it is n by n0, so it will be equal to, this term will remain same, I am not writing it again, this part will remain same, and the next part will be 2 divided by xn into f average. Sorry for my handwriting again. Okay. Now the question I've asked that the extent of reaction at which gelation will occur. So whenever gelation will occur, the degree of polymerization that means there will be infinite number of networks that will be formed between these two monomers. So in that case, the degree of polymerization will be infinity. So for gelation, xn will be infinity. So the second term, obviously 2 divided by infinity, whenever you divide something by infinity, that will be 0. So the only available thing will be percentage of conversion will be 2 by f average. You don't require to derive this every time. If you do remember this formula, that will be helpful, but I have just explained this once again. So for gelation, our conversion formula is Pc divided by 2, Pc equals to 2 divided by f average. So we have our f average value, so you just have to divide it to get our final answer, that is 0.833. Okay, so more or less everyone was able to do it. Okay, so let us move to the next question. Okay. So it says, this is the polymerization of the following monomers to form nylon 6. Okay. The weight percent of the following species when the extent of conversion is 99%. If someone is trying to say something, you can write it in the chat box. I will look at those questions. I am already seeing. Okay. Because you are not clearly audible, please write it down in the chat box. Otherwise, please mute yourself. Okay. Please mute yourself and write your queries in the chat box. I am reading them. I will get back to them. Okay. Okay. So this is the question. They have asked us to calculate the weight percent. 1 second. So they have asked us to calculate the weight percent as well as the for 99% conversion, and they have asked what is when the extent of conversion is 99%, what will be the mole percent of the monomers present. Please try to calculate it. I will tell you the solution. So to be able to solve this particular question, you have to use the 1 second. So to be able to solve this problem, you have to use the formula or statistical theory for molecular weight distribution. The slides that where the statistical theory for molecular weight distribution was told, you have to consider that. So there was some technical issue, sorry for that. Okay, so number 2 you have said 1. Mole percent, it has said mole percent, so be careful with that as well. So I can give some hint. There are some formulas about statistical theory where the relation between Wx, that is weight percentage, and conversion was given. Similarly, number of molecules present, that is Nx, and its relation with conversion, that is P, was given. You have to use those formulas. You can look at those slides as well for reference. Still now only one answer I have got, and that is for only question 2. Feel free to refer to the slides that you have read. Okay, let me show the solution for this one. There is a similar question like this. In that case, you will solve the next one, and let me show the solution for this one. Okay, so I was talking about this formula where the weight fraction or weight percentage is directly related to the conversion like this. Okay, so the weight fraction for, they have said it is 100. That means there are these repeating units. It is 100 times. Okay, it is repeated by 100 times. So our value for x is, for the first case, is 100. Okay. Now we have to put in place of x, that is 100. You already know the conversion percentage, that is 99%. So we will put 0.99, and here also 0.99, x's value is 100 minus 1. So you will get the value 0.0037. So the percentage is 0.37%. Okay. So this was the formula for weight percent. Now I think you all know which slide I was referring to. So please try to solve the next one. Just there will be the formula written just below this about the numbers of monomers present and its relation with conversion. Okay. So still no one is saying anything. Let me show you the formula. So this was the formula for number of monomers that have an conversion of, or that has formed X mers. Okay, so this is the number of species that are forming as X mers. This is n at any moment time period of the polymerization. So one second. So the now mole percent of the will be nx divided by n. So nx is the number of molecules that are X mers. N is total number of molecules that is present at a particular time. So obviously, one second. So this will be the mole fraction or mole percent, that is equal to 1 minus p into p to the power x minus 1. Now in this case they have asked us for monomers. So as they are saying monomers, so our x in this case will be 1. Rest of the things you do know that the conversion is 99%. So the value for p will be 0.99, and as it has asked for monomers, so x will be 1 when you put it in the formula, so it will be 1%. Okay. So the okay, Karan who said that it is 1%, he was correct. Okay. So let us move to the next question. This is very similar to this one. So I think all will be able to solve this. You can write down these formulas as well, that is shown here, that will help you in the next question. Write down the formulas and then you will be able to solve the next question. Okay. Please write it down quickly and then I will move to the next one. So this is the next question. It stated that a step growth polymerization is 99.5% complete. What fraction of the reaction mixture is still monomer on mole basis, and what fraction of the reaction mixture is still monomer on weight basis? So it is very easy. In both cases they have stated it is a monomer. So we already know that our X value will be 1. We already know this. Just you have to calculate once with the mole formula and once with the weight formula. Try to calculate it and write it down in the chat box and I will see. 0.005. This is the answer for 1 or 2. When you write the answer, please write it whether it is for 1 or 2 as well. Okay, so 0.0049 or 0.005. Okay. In the last question, someone said the like the average functionality was coming around 2.5 or something. So that will not be a problem, because when we set the questions in the correct answer, we do give a range generally. If it's not coming in a exact decimal, then we do give a range. Like say, if the answer is 2.5, we will get the range in the order for 2.4 to 2.6. So that will not be a problem for all. Okay, so some variation in the answer will not cause any problem. Okay, so second one, uh, first one is 0.0049. Okay, second one is 0.0001. Okay, those who have written the answer for one, please do the same for the second one as well. You have your conversion, that is 99.5%, so our P will be 0.995. And you already do know the formulas. Let me show it to you again. These were the formulas. You know the value for X, you now know the value for P. Just put it there and you will get an answer. Okay, second answer differs 0.00025, 0.00048. Okay, so the answer for the first one, everybody is giving the same answer, but the second one is quite different. Okay, okay, so let us see. The first one, everybody was correct. So on mole basis, you just have to put in place of P 0.995, and in case of X, you have to put 1 as it is a monomer. For the next one, their formula was this. So the correct answer was yes, Pooja and Karan. Yes, Arjun, they told the right answer. Anil, I think you got something wrong. The answer was not 0.0001. Just check it out here. So the value for P was 0.995 and the value for X1 1. So this term is literally cancels out. It's 1 minus 1 0. So you just have to calculate this part. So this will give the final answer will be 0.000025. Okay, fine. Let us move to the next question. This is the next question. It states the polymerization between equimolar amounts of diamine and diacids proceeds with an equilibrium constant of 400, and the initial monomer concentration is given as 1 molar. The reaction is carried out in a closed system without removal of the byproduct water. So you have to calculate the expected degree of polymerization and the extent of reaction at equilibrium. Now there are few points that you have to consider, that they are equimolar amounts. The equilibrium constant value or K value is given as 400. The initial monomer concentration is given. Also, it is a closed system. You have to be very careful. Obviously, only in case of the closed system, the equilibrium will exist. Otherwise, if you take out the water, the equilibrium will no longer be valid. So, there is an equilibrium. So, you have to calculate Xn, and extent of reaction at equilibrium means you have to calculate P as well. So there were several formulas that what conditions, like when equilibrium will be there, what formula you have to use for xn. When equilibrium will not be there and it will be an open system, what will be the change in that equation? Those things you have to consider. Now this is a closed system, so it's a very simple system. Just an reaction between diamide and diacid. You can refer to the slides. Okay, so I got some answers. I think this is the answer for 121. Okay, and the second one they have right 0.952. Okay, let's see what others are getting. This is a pretty straightforward one because it's a closed system. So the simplest formula will be used in this case. 21.952. Okay, 21. Those who are writing only the answer 1 also try to solve. Okay, Puja, yes, 0.952. Very good. Okay, only some people are constantly answering in the chat box in every case. Others also, please try. If I have to slow it down or something, please tell me. I will explain it slowly. But others also try to get the answers. I can see repeated names that are coming in the chat box. Those who are answering. Others also, please try. Okay. 0.952. Okay. 21 and 0.952. So everyone is giving the same answer. So I'm happy that everyone is able to solve this one. Okay. So this is the formula that you have to use when while calculating the expected degree of polymerization when the equilibrium constant is given. That is xn equals to 1 plus k to the power half. This is the simplest formula. So that the answer will be 21. And for the next one, the PE, you just have to do, you already know that xn equals to 1 divided by 1. Let me write it down here again. Xn equals to 1 by 1 minus P from Carothers equation. So from that this formula comes that P equals to k to the power half divided by 1 plus k to the power half. So you already know the value for k. So that will give you the answer 0.95. It was pretty much straightforward. Question number 16. Okay, so I have one request to show the question number 16. Let me go back to it. Okay. So this was question number 16. So do you have any query regarding that? If you do have any query, you can write it. I am noting them down. I will later discuss it. Okay. So this was question number 16. You can take a picture of it. And if you have any query, okay, fine. So this was the question. Let us move to the next one. So okay, 1 second. The solution is already shown in that case. Wait a moment. Wait a moment. Okay, fine. The solution is already shown in this case. Okay. Don't say. Okay. So I have already shown the solution, but you can still try to solve it. So the question was something like this: that the polymerization between equimolar amounts of diol and diacid with an equilibrium constant of 100, okay, and the initial monomer concentration is 2 molar. So same like the last question, the equilibrium constant is given The reaction is occurring between equimolar amounts of diol and diacid, and the reaction is carried out in a closed system without removal of the byproduct. So the closed system means there is an equilibrium. So they have asked us to calculate the expected degree of polymerization, the extent of reaction, just like the previous one. But the third question is a bit different. The level of H2O that must be lowered in order to obtain a degree of polymerization of 100. So for the third question is new, where you have to calculate the water concentration, for which how much you have to lower the water concentration to get a degree of polymerization value of 100. Okay, so try to solve this. Be very careful about the third one, because as it states that H2O must be lowered, that means you are taking out water from the system. So that system no longer remains a closed system, right? It becomes a open system. So you have to go back to the those slides where Sir has discussed about the open system. Only then you will be able to calculate the concentration for water. Okay. One is 11. Okay. Okay, you can solve all the question and then can write the answers as well. Okay. 1, 0.909, 1.81. Okay. First one, everyone is saying 11. Second one, they are saying zero point 0.9. Okay. Try to calculate. Okay, 0.91. So everyone is still giving the same answer. Good. Third one is 0.021. So Karan and Pooja has quite difference in their answers for the third one. Okay. Others also please try to do the third one. 'Only two answers I have got for three, and they are different. So others also please try to solve the third one. 11 and 9, 9 or zero point 0.9. Okay. 11 and 9. 0.02. Okay. 0.02, is it the answer for the third one? Okay, yes. 0.02. Fine. Okay, for the third one. Yes, 0.21. So now Karan has the same answer with Dr. Tripathi, but Pooja has a different answer. Okay, so let us see that which answer was correct. So the correct answer was 0.02. I think you all were able to solve the first one. It is the same formula, xn equals to 1 plus k to the power half. And for extent of reaction, it was the same formula and it was giving the answer 0.909. So for this third one, what will happen? So you have your, initially you have your equilibrium constant, which you can write as, let me do it. You have the four terms, like it's a reaction between diol and diacid. So there are four terms. One is COOH, that the diol concentration. One is the diacid concentration, and one is the diol concentration. One is the concentration for your product, and another is the concentration for water that is coming out from the system. So that was your equilibrium condition. Now for equilibrium, you just replaced this C or product concentration by C0 into PE, both for the product and water when it was a closed system. And for OH and COOH concentration, it was C0 minus C0 into PE. So from that, the initial equation was coming. Now, as the system is no longer a closed system but an open system, so in place of H2O, you cannot put C0 into P because you are taking out it from the system. So, others will remain same. In place of COO or the product, you can write C0 into P. In place of OH and COOH, you can write C0 minus C0 P. But in place of H2O, you have to keep it like that. So this will lead to a equation like this, where K equal to, let me write it down, P into H2O concentration divided by C0 into 1 minus P whole square. So this equation will come for open system. Now you have to calculate this H2O, and you also do know that Xn equals to 1 divided by 1 minus P. You just have to replace this in place of that, which will ultimately result in the equation H2 equal to Kc0 divided by Xn into Xn minus 1. So K value is 100, it is given, okay. C0 value is 2 molar, that is also given. Xn, that the desired degree of polymerization is 100, that is also given here. So once you put all those, the final results comes as 0.02 molar. Now the interesting fact that I think Professor Dhara has already discussed in his slides, that before, when the system was a closed system, there was an equilibrium, you see that the average degree of polymerization was only 11. So that was the need for which we required to take out the water molecules from the system. Because even if the K value was 100, you can only reach up to a degree of polymerization value of 11. So you can never get a higher molecular weight. So for that, we have to take out the small molecules that are generating in the system. So once you start taking them out, you can see that you have to, the water concentration, you have to lower it by 0.02 moles, okay. Only in that case you can reach up to 100. The degree of polymerization only reaches 100 even when the H2O concentration is in such low, like 0.02 molar. So how crucial it is to remove the water molecules during your polymerization, it is very much evident from this problem, okay. So let us move to the next one. Okay, so week 2 lecture materials was up to this. So now we will start the questions that are from week 3 lecture materials, and let us see how many questions we can solve. Okay. Okay. So this is the first question from week 3 lecture materials. It states that consider monomers of general structure CH2 double bond CHX in the following table. Positive means that the monomer can be polymerized by this pathway. I mean, if positive is written under free radical, that means it can be polymerized by this pathway. And if it is written negative, that means it can't be polymerized by this pathway. Okay. So you have to choose the correct option from both these tables. This is table number 1 and this is table number 2. So randomly this is placed. You have to select the correct option that for which I have written it correctly. For 3 of it, free radical, anionic and cationic. You have to select it. When you write it in the chat box, write like table 1 or for 1, which is the correct answer, and for table 2, which one is the correct answer. And let me tell you, this is a MSQ question. So the correct answer can be more than one as well. Okay. So when you write it down, write like for one, which are the correct option, and for two, which are the correct options. Table 2 is D. Okay. Just try to think it that whether it will stabilize the free radical or any anionic species or cationic species. Okay, so look at the functional groups and try to think whether they will stabilize a radical or anionic or cationic species, and then you will be easily yeah, you can easily tell the answers. So far only one answer I have got. Just try to think whether okay, for one it is C and two it is D. Okay, now let me give the hint again. For one of these, it might be two or more than one options. Okay, correct. Might be that two or more options are correct, or one or more options are correct for one of these table. As I have already said, it is an MSQ. So try to think it out. 1D. Okay. So I have one answer, one C, and two answers is 1D. Okay. Just think about their, okay, 1D, fine. That whether it has a minus R effect or plus R effect or minus I or plus I effect, what kind of effect they will have on the anions or cations or radicals. 2A and 2D. Okay. So the answers are quite are varying a bit. 2A and 2D. Okay. Others also please try to write. It is fine if you get the answer wrong. Okay, it is fine. But you will be able to just solve the question by yourselves in the assignments or in the exams later if you try. 2A and 2D. Okay. Just saying 1D and 2B. Okay, so most of the time the answer for table 1 is 1D. Okay, let me check the correct answer for the table 1 is 1D. Why? Because COOH3 obviously that will be able to do a free radical polymerization fine. It will stabilize a anion. Okay, so it can undergo an anionic polymerization because this COOH3 group can stabilize in case of anion, but in case of cation it has no stabilizing tendency, like it only does have a minus R effect. Okay, but it does not have any plus R effect or anything, so it cannot stabilize a cation but it can stabilize an anion. So for that case the uh, this option is only correct, that is free radical will occur, anionic polymerization will occur, but cationic polymerization will not occur. For this is not true. OCH3 cannot stabilize anionic polymerization, so it is wrong. pH can stabilize cationic polymerization, so it is wrong again. And CN group cannot stabilize anionic reaction, so it is wrong again. Okay. And for the second one, let us seek the correct answer. Someone has said for 2, B and C. Okay, so you are correct, Roja. The correct answer were B and C. So many people have said C, but I don't think anyone else said B. Because look at the phenyl ring. It is a quite interesting group, right? Obviously, it can do free radical polymerization because it has the tendency, it has these double bonds by which it can form resonating structures around the radicals. Now, pH group is very much interesting because it can both show minus R or plus R effect, and neither of them are too strong. Not too strong, but in both the cases, as it has many double bonds in its structure, so it can both stabilize an anion and a cation at a particular time. So it does not have any strong minus or a plus R effect, but it does have sufficient amount to stabilize it for the polymerization reaction. So for pH, all the reactions will occur. So that was another question, and you have already answered that for COOCH3, free radical will occur, anionic one will occur, but the cationic will be that particular will not be stabilized. Okay. So the question is why some people wrote that OCOCH3 that can stabilize. So this answer many one has written 2D, but think of it that in case of that, whenever it is a anionic polymerization, it can stabilize in case of anionic polymerization, but for free radical polymerization that will be difficult. So this option is not correct, so that's why the option D will not be correct. Okay, so up to this was the question. Let us move to the second one. Okay, so this is the second question, quite a big one. Let me see. A typical radical polymerization is being carried out with the following assumption, that the initiation is by thermal dissociation of initiator, steady state and equal reactivity of propagating radicals. Termination of reaction is only by bimolecular coupling and no chain transfer. So there are many assumptions that are taken here. Okay, what will happen to the polymer's molecular weight and RP or rate of polymerization when you increase the monomer concentration and increase the initiator concentration? Now this question looks a bit large, but actually you just have to consider the rate equation for where the polymerization is initiated by thermally activable initiators. So there was a part where Professor Dhara taught you that for thermal initiator, what is the rate equation value. Just go to that slide if you do not remember the formula, because it's a big one. If you do not remember that currently, just go back to that slide, you can check it out. There you will see what is the relation between RP and monomer concentration and initial concentration, and what is the relationship between molecular weight and monomer concentration and initiator concentration. Just to the slide where the thermal activable initiators were discussed, the kinetics for thermal polymerization. Okay, but you have to remember these equations actually. For if some of you are taking the exam, then you will have to remember this equation. For assignments you can just check the slides and can answer them, but for who is if any of you are taking the exam, in that case the equations will not be given most of the cases, so you do have to remember those equations as well. decrease, molecular weight decreases, rate of polymerization increases. Okay, I have got one answer. Second answer is decrease in molecular weight. Okay. So there are two questions. In one, you are increasing monomer concentration, and in the second one, you are increasing initiator concentration. So please write it down whether you are answering for question 1 or question 2 as well. Okay. If you have found the slide where Professor Dhara has taught about the rate expression for thermal initiation, then you can see that the other assumptions that are written here are already taken while deriving these formulas, like the equal reactivity of propagating radicals, termination by bimolecular coupling, and no chain transfer, all were already considered during derivation of the formulas. So these are just stated so that you do understand, but the final formula is same. Okay, so one answer is molecular weight decreases for second and rate of polymerization increases. Okay, first one, both molecular weight and rate of polymerization increases. Okay, rate of polymerization increase and molecular weight decrease. So again we are having a variety of answers. Molecular weight decreases, RP increases. Okay, okay, so let us look at the answers. So if you, so these oh sorry, I should have shown the answers as well. Okay, so these are the correct answers. The first one is the correct answer for 1, and the second one, that is option C, is correct answer for 2. Why? Let us see. So this is the equation for rate of polymerization. If you do have the slides in front of you, the rate of polymerization equation was Rp equals to Kp into monomer concentration, Kpm, into FKDI divided by Kt to the power half, where those Kd, Kt, F and Kp, those are all constants, right? Those are all rate constants and functionality, etc. But the variation of Rp was Kp into m, that means Rp was proportional to m and it was proportional to I to the power half. Whereas in case of molecular weight, you know that for molecular weight, Mw, the molecular weight will be, one second, the molecular weight is M0 into Xn, or we can write it like it is M0 into degree of polymerization, and while the reaction is proceeding, you know degree of polymerization is related to, like Xn is related to kinetic chain length by 2 into nu, where nu is the kinetic chain length. And if you, so we can say the molecular weight is proportional to the kinetic chain length. And if you look at the formula for kinetic chain length, it is Kpm divided by 2 into FKD I to the power half. So we can write it down that it is proportional to m and inversely proportional to I to the power half. So in the first case, where we are increasing monomer concentration, for that rate of polymerization will be increased, it is directly proportional, and molecular weight will also increase because it is also directly proportional to m. And in the next one, where you are increasing the initiator concentration, Rp is directly proportional to I, so Rp will increase, but molecular weight is inversely proportional to I, so it will decrease. So it is a very important question. So you do have to remember these equations for thermal initiation if you are going to take the exams. Okay, fine. So okay, we will take a break after this question. Let us solve this. It is a easy one. So it states that polymers were obtained by polymerization of styrene initiated by thermal decomposition of benzoyl peroxide at 80 degrees centigrade. Fine. In the following solvents. What solvents? Benzene, 1-butanethiol, isopropyl benzene, and carbon tetrachloride. In which solvent the molecular weight will be lowest, assuming chain transfer only to solvent. So we do know that during polymerization there occurs some chain transfer reaction that can happen with other monomers or initiator or solvents, etc. But in this case they have asked us to assume that the chain transfer is occurring with solvent only. Now you see that benzoyl peroxide is being used at 80 degrees C. Now these are the solvents. So in which case the molecular weight will be lowest when the transfer reaction rate will be highest. I mean the more will be the transfer with the solvent, the lesser will be the weight of the polymer molecule. So you just have to see that in which case the transfer will be most from the solvent to polymer molecule. So in that case, molecular weight will be lowest. Try to think it. Okay, so someone is saying A, some D, A. Okay, one has said 1-butanethiol and one other says carbon tetrachloride. Okay, others also try to guess. Okay, so let me. I have already written down the answer. The correct answer is 1-butanethiol, because the SH bond that you see is very much susceptible. Someone is written down carbon tetrachloride. Yes, carbon tetrachloride is also a bad solvent, because in that case also the transfer will happen. But among these four, this SH bond will very easily try to remove this hydrogen from it and try to form a SS bond among itself as well. So it will always try to transfer this hydrogen molecule to the growing chain. So the most probability of the solvent which will transfer chain transfer reaction will occur is butanethiol, because it will always try to remove this, break this bond, form a dimer, and then this H will be transferred to the propagating radical. So the correct answer for this particular one was 1-butanethiol. Okay. So we do have a similar question like that, but we'll get back to that after the break. So let us have a 10 minutes break and then we'll be back. Meanwhile, if you have any queries or regarding the questions that I've already discussed, then you can ask it here. And it is 8:05, so I'll be back exactly like at 8:14. Okay. So let us take some break and we'll be back soon. Okay, so let's start again. We have our break. So let's start with the question that we are left with. Let us move to the slide. So this is the fourth question, just as I have said, similar to the question number 3. It states that polymers were obtained by polymerizing of styrene initiated by thermal decomposition of benzoic peroxide at 60 degrees centigrade. In the following solvent, cyclohexane, 1-butanethiol, isopropyl benzene, and carbon tetrachloride. The order of the molecular weight produced in the solvent follows. So the last question just asked you to select the solvent that was least favorable to get a high molecular weight. Now this in this question they have to you have to just properly arrange them in a order, that what is their order. So again in this case as well, for which solvent the exchange will be highest, that will give you the lowest molecular weight, and in what case you will have the lowest chain transfer, that will give you the highest molecular weight of the polymer. Okay, so try to think it that in which case it will be stable or not. You already do kind of know the answer, I think, from the last question. So yes, we have our first answer, it is C. Let us see what others are saying. C. Okay. Okay, so everyone is saying C. So it was very obvious. So just in the last slide, I have said that 1-butanethiol was the most capable of chain transferring among all the solvent. Next to it, obviously, that will be carbon tetrachloride. The CCl bond is very easy to break in that case. Next one will be isopropyl benzene, the hydrogen from the isopropyl group that can transfer. Now, in case of cyclohexane, the CH2 bonds that are not very good for breaking and getting transferred to a propagating radical. So, in case of cyclohexane, you will get the highest molecular weight because it will have the least tendency to have any chain transfer reaction with the radicals. Okay. So, let us move to the next question. This is a very easy one. So, it states if the half-life time, that is T half, of an initiator in toluene is 10 hour, calculate its dissociation rate constant Kd in the units of reciprocal of hour, that is hour inverse. Okay, this is a very easy question. I will give like 30 seconds or so and just try to solve it. 0.0693, 0.0693. Okay. Okay, so I will not spend much time in this because everyone is telling the correct answer, because the next question will be more tricky. So obviously this was the equation, that is I equal to I0 e to the power minus kdt, that you get from this rate equation, that is minus di by dt, sorry, minus di by dt is equal to initiator K dissociation into initiator concentration. Just forgive my bad handwriting again. So that this will give you the equation, and as it is a first order equation, so you will have Kd equals to 0.693 divided by T half. So this was our answer, 0.0693. So it's very easy. I show that so that you can solve the next question. This will be the better question than the previous one. So it states a solution of 0.1 molar monomer and 4 into 10 to the power minus 3 molar, that is the initiator, is heated at 60 degrees centigrade. How long will it take to achieve 50% conversion? Assume all rate constants are A being independent of conversion. Okay. So these are the rate constant that is given. Kp, Kt, F is also given. T half is also given. So you have these all values. You have one rate constant that is not given, that you can calculate, that is Kd, just like the previous one, and then you have to solve it. Okay. How long the hour will be taken. So you can also again take the help of the slide, because this will have a big equation you will require. So you can look at the slide. There is a equation where the conversion is related to the initiator concentrations and the rate constants, etc. for thermal initiation. Okay, just go to the slides for thermal initiation and look for the equation that relates conversion with the rate constant and initiator concentration, etc. And then put this value. All values are given. Once you find that equation, you just have to put all these rate constants and other values that are given, and you will have your answer. 186 hour. Okay, so this is actually an easy question if you do remember the equation. If you do not, then that can be problematic during your exam. Otherwise, it is a pretty straightforward question. We have one answer, that is 186 hour. Okay, let us see what others are getting. What you all can do, you can join from phone and look at this question, and if you do have laptops, then you can open the slides from week 3 lecture materials, then that will be easier for all of you to solve these questions. Okay, so again 186 hour. Okay, let's wait for others to solve this as well, as I have only got 3 answers. Okay, let me show the formula for others to calculate. So first you need to calculate Kd from the similar formula as you used in the last question, that is 0.693 divided by T half. So you have your Kd value in second inverse, but be very careful because these all values are in second, and it has, I think, asked you to calculate the time in hours. So while giving the answer, everybody is giving here, but while calculating in during the exam, be careful in what unit the answer is asked. Okay, so you calculate Kd, then this is the formula which relates percentage of conversion with the rate constants. So you can see that the monomer concentration, it is not actually required here, because you can just directly put the conversion, that is 50% conversion here, and put the value for initiator, and all other constant values are given. You can just put it and then you will get the answer. You don't actually need to know the monomer concentration, it is just to mislead you in a way. Okay, okay, so 3 answers I got. So others, please also try to, now you do have the equation. So please put the values of all the constants and try to find out the t. Okay, so this will be the calculation. I am showing it again. Everything is given, you just have to put those values. And okay, I was getting the answer was written 188.9. Maybe something I have taken something or so. So that is not a problem. Everyone has given the answer is 186 hours. So there might be some error in this calculation. But as I just have mentioned that there will be range that will be given. So it will not be any problem. Okay. So this was the question. So all of you did not answer. Just write down the formula and then just put the values and you will get the value for t. Only unknown is this t. Okay. So let us move to the next question. So this is our next question. It states that the benzoyl peroxide initiated polymerization of a monomer follows the simple kinetic scheme with all rate constants and if being independent of conversion. This is a very important point, otherwise you cannot calculate. So the for a polymerization system, you have your initial monomer concentration 2 molar, you have your initial initiator concentration 10 to the power minus 2 molar, and the limiting conversion, that is P infinity, is 10%. Now they have asked to increase the limiting conversion to 20%. How much you should increase the value of the monomer, initial concentration of monomer? How much you have to increase to get the P infinity value to 20%? Okay, this is also a question from the same expression like rate equation for thermal initiation. So at the end of the polymerization, that is T equals to infinity, you have your conversion P infinity. So just look at the slides and try to get this answer. A similar type of question I think is in your assignment as well. So if you are able to solve this, you will be able to solve the question of your assignment as well. 4.48, okay. 4.4855, okay. I think this problem was somehow discussed in the lecture that was given by Professor Dhara. I should have changed it a bit in that case. I don't exactly remember. I think this was discussed in the class as well. So everybody should be able to answer it. 4.4885, okay. So one question is, how did you get KD in previous equation? Okay, so let me explain it now as well. You are using the same formula for KD here. So it is a first order equation, rate equation, right? Minus dI dt is proportional to KD by I. Once you solve this, you get this rate equation, I equal to I0 e to the power minus kdt. So at t half, that when t will be t half, the I will be I0 by 2. So once you solve that, your t half will come as 0.693 by kd. Okay, this is just the same equation that you use everywhere for first order rate equation, for first order rate constant. So it was a first order rate equation. So by this formula we calculated kd, and the second for this problem as well we calculated kd using the same formula, 0.693 by t half. Okay. Okay. So everybody was able to answer this. I think this question was discussed during the lectures. So you again have to use the same formula here. Now once you put infinity, that at time t equals to infinity, if I go back, you are using this same formula for the next problem, right? Just when t equals to infinity, now you have your t equals to infinity, that will give your ln of 1 minus p infinity. So in place of time you have to place infinity. Once you put this e to the power minus infinity, so that will come as 0. So this part will no longer be there. 1 minus 0, that will be 1. So this part is no longer there. So the only part that is left is minus of ln of 1 minus p infinity is equals to 2 kp f I 0 divided by kt by kt. Now see, others parameters, that is f, kd, kt, kp, these are all constants. As it has been said that irrespective of the conversion, these values are same. If these values will change, then you cannot take them as constant. As it has been said that they are constant for any conversion, so these values will be same for 10% or 20%. So the only varying parameter here is I0. So you then just have to put, like you have to change it from 10% to 20%. So 20% means 0.2, 10% means 0.1. So that will be proportional to I0 for 20% and I0 for 10%. Now you just have to calculate this minus ln of 1 minus 0.2, that will come 0.2231, and minus ln of 1 minus 0.1, that will come as 0.1054, and that will give you 2.117, and there is a root in this equation, and when it will become a square of this term, so you will have the ratio of around 4.48. So this is a easy question but an important one for your exams as well. Okay. 7, 8. Okay. So this is the next question. Let us look into that. So it states that in a typical thermally initiated free radical polymerization at steady state, rank the following according to their values. That is rate of initiation, rate of polymerization, and rate of termination. So what would be the answer? This is a very easy question as well. Others also please try to answer. I see one answer. Okay. Others also please try to answer this. We see this is also very easy one. Screen is blank. Okay. Can others see the screen? Or it is not visible. Okay. So let me read the question for you if you cannot see it. It stated that in a typically thermally initiated free radical polymerization at steady state, rank the rate constant values or rate values, that is rate of initiation, rate of polymerization, and rate of termination. These three values, initiation, propagation, and termination, where what will be their order, which will be greater than what? Screen showing question 7. Okay, I think this might be some internet issues in that case. Screen is blank. Question 8 is visible. Only one person is saying that it's visible, others are saying it's not. Okay, let me remove it and try to present again. Okay, so please see that whether you can see it now or not. Someone is saying now visible. Okay, 7 question is showing. Okay. Okay, so many are giving answers, so I guess others can see it. it might be a network problems for others. B. Okay. Okay. So this was a pretty easy question. So obviously it's a steady state. So in case of steady state approximation, we just approximate that as soon as the radicals are forming, they are taken up, so that Ri will be, so as soon as they are generating, they are propagating so fast that we are getting the termination as well. So this is the approximation for steady state. So Ri will be Rt. Again, the Rp or rate of propagation is generally very fast compared to the initiation or the termination process. So that in general we do consider that the rate of polymerization is actually the rate of propagation in general. So the correct answer for this case should be D. No, those who have said C, that will not be correct, because see, it has stated as steady state. Look at the steady state approximation that we took for thermal initiation reaction, that as soon as the radicals are generating, that are getting inactivated by reacting with each other or other species. That is the approximation for the equation from which we got all the equations. So the final, say, option B will be correct in this case. Okay. So this is a very easy question again. So consider a radical polymerization reaction initiated by the following species. The species is given here. So they have just asked what kind of initiation process is this. I think anyone can say it. Plus, okay, but for this session purpose, I have to discuss all the problems as well. I have put the numerical problems here as well, but I am also obliged by some rules. I do have to discuss all the questions. Okay. I will try from next session. What we can do, we can put the numerical question first, so that we can solve most of them, and then we will leave the theoretical questions for the last. But I do have to discuss all of them, because you might not have any problem in those, but someone might have some problem in the understanding. Okay. So I will not spend much time in this one, because everyone know this. So this is an example for redox initiation reaction, and this was the reaction that is happening. So this was a easy question as well. Okay. So this is the number 10 question. It states styrene was polymerized by heating to 100 degrees centigrade, and it was taken from 4 different bottles for 4 concentration that may contain impurities. Okay. So carb 1, that is for the pure styrene. Identify the nature of impurity that are present in other bottles that are causing the carbs 2, 3 and 4. Okay, these are the nature of the carbs. This is for the pure one. This is for the ones who have impurities, and they have asked us to identify the type of the impurities. So some are saying D, some are saying A. Okay. One second, okay? Let me see one thing. Okay, so answer for this question was as already. I cannot understand the question. Okay, so it states. So I think many people are saying many things. Yeah, I will try to finish the third week by today as well. There are not many questions left. I just saw, so I will finish them. Okay, some question is how will be the graph in case of accelerator. So just the opposite that from retarder. In case of retarder, you are reducing the rate. You are reducing the rate of the reaction. In case of accelerator, you will increase the rate of the reaction. So that will be something like this. 1 second. So you will just increase the reaction. So most of the people has seen the option A is correct. So someone has said you are not able to understand the question. Okay, so it states that suppose you are polymerizing styrene. So you are polymerizing, but you are taking the styrene for foam from 4 different bottles. So number one bottle contain pure styrene. Okay, so it is the curve for your pure styrene, but the other 3 bottles have some impurities in that in the container. Okay, so when you do polymerize, you did not get a curve like one, the pure one, but instead you get this kind of curves. So now you have to understand what were the type of the impurities that can lead to this kind of graphs. Okay, so the correct answer, as everyone has said, is the second one. How? Because look at the second one. It is for the 2. It is an inhibitor because it completely stops the reaction when you add this in the system. So see, for 2, in this portion there is nothing. That means the reaction was completely stopped at that point. Uh, until the point the inhibitor is present, you will not have any polymerization reaction happening. So the reaction is completely stopped, and once it is once the inhibitor is totally consumed, the rate will slowly go back to the initial one. The curve should look more like this. Okay, it is being written like this, but it should more look like this. It will go to the original rate value. Slowly it will go to the original one. Okay, just like where 1 was there. And the curve 3, it is for retarder. So retarder just decreases the rate of the reaction, nothing else. So you can see it cannot stop the reaction, but it somehow decreases the overall rate. So the 3 is for retarder. And the fourth question is, this is the fourth one. It states first you have added inhibitor, so up to that point there was no polymerization occurring. Now if you had only put inhibitor, so once the inhibitor is consumed, the rate should be slowly go to the first one, but it is not going. You can see the rate is very slow yet. That means you are adding inhibitor and retarder. So once the inhibitor is consumed, the polymerization starts, but the retarders are still present. So the rate will not be equal to 1. It will be very much lower than 1. So the curve 4 is for inhibitor and retarder. Okay, so let us move to the next question. I think you all know this too. Let me, okay, I have one question left. Okay. So it states on increasing the temperature of the free radical polymerization reaction, the molecular weight of the produced polymer nearly remains the same. The possible initiation, what is the possible initiation mechanism? So just quickly give this answer. There is no need to spend much time it in as well. B, okay. Redox, yes. Okay. So yes, for this the correct answer will be redox initiation. Now in this particular problem, it is not a numerical problem, but do consider in some cases you might have to remember this equation, because from this equation many problems will arrive. It can arrive in your exams as well. So try to remember this equation. So this was the equation that you got from Arrhenius equation, and once you put the values for this three EP, ED and ET, you will see for redox it is almost equal to 0, for thermal it was negative, and for photochemical it was positive. So in this case it is stated that it is a uh, yeah, what is it critical the molecular rate of the produced polymer nearly remains the same, that is the change is 0. So obviously the possible initiation mechanism in this particular case will be redox initiation. Okay, so this is another numerical problem, try to solve it. Molecular weight, acha. Yes, I just have said that in case of that it is negative, so the it will decrease. Okay. So consider a thermally initiated radical polymerization with no chain transfer reactions and termination only by a bimolecular reaction between the propagating radicals. That is a very important point. At the end of the reaction, the polymer produced contains 1.25 initiator fragments per molecule. What is the percentage of chains that got terminated by coupling? So this is a numerical problem. This is also an easy one if you do remember how to solve it. Uh, 40, okay. 1 second, okay. 1 second. Okay, I think the 12th question was the last one. Please take a picture of the question and let me, as we do have, we'll have 5 minutes more to solve another question. Let me see if I can find some more question, okay. Just try to solve it, take a picture of this question and try to solve it, and then give the answer in the chat box. Meanwhile I will stop presenting and let me find out if I can get some more questions for you to solve, okay. Just take a picture of it. Okay, then try to solve it. Let me find more question. I am stopping my presentation for some time. Stop. 25. We have two answers. One is 40, another is 25. There are two answers. One are 40 and 25. Others also try it. 40, okay. going back. 40%. Okay, let me go back to this question. Let me try to present again. I hope you are able to see the screen. So yes, the answer was 40%. This is the derivation of the formula that you need to do for to answer this question. That is, the final equation is, one second. The final equation is this: a equals to 2b minus 2 by b. You have to remember this particular formula, where a is the fraction of propagating chains which undergo termination by coupling, and B is the average number of initiator fragments per polymer molecule. And then you have the relation between these two, that is A equals to 2B minus 2 divided by B. Now in this case, it has asked that what percentage is getting terminated by coupling. So you only have to determine A, but in case of assignment or in the exam, be very careful. Sometimes it states that what fraction of propagating chains are undergoing termination by disproportionation. So just don't stop at getting A. In that case, you have to determine 1 minus A. So read the final line. Otherwise, it is a very easy question, but read the final line whether it is asking for A or 1 minus A. Okay. So I don't understand. Okay, this is just the basic derivation of this equation, right? So if you have A number, the fraction of propagating chains that are terminating by coupling is A. So to overall we can take the fraction is 1. So the propagating chains that will be terminated by disproportion, that will be 1 minus A. Okay. So if there are n number of molecules, there will be, this will be A n, and this will be 1 minus A divided 1 minus A into n. Now in case of this, when we have to get the total number of molecules that are there, you see during the termination by coupling, two radicals molecule are coming in contact with each other, right? Termination by coupling, that means when they are terminating, this contains one I species, this also contains one I species. Madam, so, I think you are muted. Okay, look, 1 second. Ma'am, you are not audible. Okay, 1 second. Okay, very sorry for that. So I have to explain it once more. Okay, so as I was saying, that it states that A is the number of fraction that is getting terminated by coupling. So if the overall fraction is 1, so the other fraction that is getting terminating by disproportionation will be 1 minus A, because the total is 1. So if there are n number of molecules, so that will be A n and 1 minus A into n. But while calculating per molecule, when I taking that per molecule, how many numbers are there, why we have to divide in this case by 2? Because when you are thinking about coupling, there are two radical species. So this will be another one radical species, and this is another radical species. These two are coming together and forming one polymer chain by termination. But this propagating radical has one initiator molecule. This propagating radical also has one initiator molecule, right? So when they are getting terminated, so in the terminated species, you originally have two I species. So you are calculating twice. That's why there was a division by 2 in the final formula. and you get A equals to 2B minus 2 by B. For the disproportionation one, that doesn't happen because each polymer chain has one initiator molecule, but in case of coupling, as one polymer chain has two initiator molecule, you had to divide it by 2, and this is the final formula, and you get your percentage as 40%. Okay, you would not be requiring the value of n at all. This is cancelling out. So I did five. We have 5 minutes left. So I did find this question. There are not many numerical problems left. I have just checked. So this is one. I have just hurriedly pasted here. Try to solve it. It states the equilibrium monomer concentration for radical polymerization of 1,3-butadiene is 77 degrees C is in the order. You have to get the order for this equilibrium monomer concentration, and the value for delta H and delta S is given. I think that will be solved. Okay, I already have one answer. Please others try to solve this as well. See, I do only have one answer, so others also please try to solve this. You have to consider the slide where the thermodynamics of polymerization was discussed. Okay, if you have the slides, then go to the slides where Professor Dhara has discussed about the thermodynamics of polymerization. There you will find the equation that will be required to solve this question. Okay, so we don't have much time left. Let me quickly show you the solution. So this is the answer. How it is coming? If you go to the slides, then you will see, you already know that delta G is equal to minus RT ln K. You know this equation. Let me write it down. RT ln K. Okay, this is the equation. This will be at equilibrium, this will be delta G equilibrium, and K will be the equilibrium constant as well. Now you also know that delta G is equals to delta H minus T delta S. Okay, now you have your delta H value, delta S value that are given, and also the temperature is given, so you can get the value for the equilibrium constant. So once you get the equilibrium constant value, K equilibrium is actually is equal to 1 by monomer concentration. Other equation, just normal thermodynamic equation, you know that delta G is equal to minus RT ln K, and you also know that delta G is equal to delta H minus T delta S. So you can easily calculate the K equilibrium, but you have to go back to the slides where it was discussed that what is the K equilibrium value, and that is equals to 1 by monomer concentration. So obviously the monomer concentration will be e to the power that K equilibrium. You get your K equilibrium value minus 14.4, and when you put that, you will get 5.6 into 10 to the power minus 7. So yes, those who have answered, the correct option is C. So it is 10 to the power minus 7. So I don't think there are many there are different types of problems left. Maybe one or two theoretical questions are left, but I think you'll be able to solve it. So there will be no need to continue lecture 3 in the next session. So we'll directly go for week 4 lecture materials. So I think this is it. Thank you all for listening to it patiently, and you can ask your questions in the portal. Okay, I will stop recording. And thank you very much. You all can leave now.